Okay, I go. Okay, first of all, thanks everybody for joining this session with us today. My name is Lorenzo Vecci. I'm a PreSales Engineer at Security Gen, and today we want to offer you this journey through the topic of ORAN Security, because in recent months, in the last year, let me say, we've been involved a lot in projects related to the security of ORAN. ORAN is a topic that has gained a lot of traction in the industry recently, and today we want to offer you our perspective and the perspective also of the industry itself. So the presentation is split into 3 chapters. Let me go with chapter 1. Let's set a common ground. I will talk about the industry requirements and a bit the history of ORAN, why we arrived at ORAN. Well, let's start from the first step. Virtual RAN and Cloud RAN. Cloudification now is, or let me say, virtualization is 10-year-old. And the first wave was related to coordinator functions, but soon after also RAN functionalities, radio functionalities were involved. And the first wave was about virtualizing some of the layers of the radio stack. The radio stack goes from physical, let me say, functions related to manipulations of electromagnetic signals, radio frequency, up to radio resource control functions, which are highly logical. So some of these functions must stay at the antenna, no way of dragging them out. Some other can be localized at COTS hardware, can be deployed over COTS hardware, over general purpose CPUs, sometimes helped by accelerators like GPUs or FPGAs, but more or less you can try to strip out some of the functions out of the radio stack and put them on COTS hardware. And let me say that the main achievements of the first wave of virtualization of the RAN were the study of the split of the functions between distributed units, closer to the antennas, closer to the sites, and centralized units, which can be, as the word itself says, centralized in more central locations. Of course, one of the main targets of this step was understanding which of the functions could be deployed on data center-like infrastructure, on COTS hardware, let me say, on servers. And of course, this first exercise helped the operators think about how to distribute DUs and CUs, depending on performance, depending on the availability of transmission infrastructure, because the more you can distribute, the more infrastructure you have for transmission, the better you can distribute. Cloudification plans, synergies with other initiatives related to cloudification. These were let's say, the key achievements of this first wave. But it's also important to say that this effort was still fought in terms of single vendor philosophy. So a single vendor providing all the bits and pieces of a RAN. And still, there were no new use cases connected to the use of a RAN. So basically, with Open RAN, the industry tries to achieve much more. First of all, of course, expanding the use of cloud native technologies, go beyond virtualization to cloud native functions, develop synergies with the deployment of data centers used at the edge, in example, for multi-access or mobile edge computing, improve the use of orchestration and automation, which is key in cloudification. But what is really new is, and now we move to the left-hand side of the picture, first of all, having a multi-vendor RAN, which doesn't mean assigning the north of the country to vendor A, the south to vendor B, which is the practice today, but actually is inside the same RAN deployment, buying the best functions. In example, the centralized units in theory from vendor, certain vendor, and the intelligent controllers from another vendor. And we will see the role of these different names along the presentation. But again, this is also in order to achieve less risk of vendor lock-in. It's important, and also to stabilize the supply chain against any kind of risk, basically, also geopolitical. Very important, what you see in the center here, it's the new use cases, because RAN now must provide advanced and added value use cases to bring money maybe in synergy with MEC, multi-executive computing, by using artificial intelligence and machine learning approaches to the use of data. So the industry launched the new initiatives in order to achieve all these targets, like ORAN under the TIP, Telecom Infra Project sponsorship, and ORAN Alliance. And today we will focus on the ORAN Alliance that was started in 2018 by five big operators. Now, let me see today who speaks up really loud for Open RAN. I just want to give you this example. And a white paper published back in November 2021 by these five big operators. And their point of view in example is that is strongly linked to the European Union. So it is not applicable to all geography, but basically they speak up because they think that Open RAN will increase resilience and stabilize the supply chain, bullet 2, very important. That Open RAN will foster innovation across industries. So RAN will fertilize other use cases and vice versa, and this is bullet 1. Bullet 3 is applicable to Europe, so Open RAN will maintain and increase EU competitiveness and technology leadership. And these operators also call for strong EU policy-making initiatives to sustain Open RAN. So there is also some political push. And let me say that these five big names anyway don't tell us much about cybersecurity. They have some tables, some Excel files, but most of the works on cybersecurity are delegated to other entities in the industry. So now, after setting this background, let me give you an overview of ORAN architecture. So we will focus on the ORAN flavor of RAN. You will see functions which are specified by FreeGPP, like the centralized units, control plane or user plane, what you see with CUCP or CUUP acronyms, or the distributed units, ODUs. These are all also the user equipments, the old style node Bs, indicated here as O-E node B. These are FreeGPP functions, and the related interfaces are also specified by FreeGPP. But ORAN, anyway, introduces the service management and orchestration framework at the very top of the picture, which is the control center of the control room of the cloudification. Also, ORAN defines the RAN intelligent controllers, RRIC for short, and we have a non-real-time and near-real-time, which these are the control centers for the advanced services. ORAN introduces also OCloud, so a cloud infrastructure, defines new interfaces like O1, O2, A1, E2, and also the OpenFrontal. And ORAN doesn't want to overlap with FreeGPP, okay, but elaborates further on the functional split between distributed and radio units, fostering more opening at the level. Okay, now let's see the different components a bit more in depth. The SMO is where you have all the FCAPS functionalities for the RAN network elements. So basically you have fault configuration, performance, and security functions. Let me leave alone accounting, which is not really applicable. It's the platform for the non-real-time RAN intelligent controller. And this is where you control the cloud. You orchestrate resources, you do workflow management. The OCloud, well, the OCloud on the right-hand side is not defined explicitly by ORAN Alliance. ORAN Alliance just provides the expected functionalities, which are virtualizable, let me say, hardware, server switches and storage with some accelerators, an environment for running and managing virtual machines and containers, plus some other cloud management functions. Basically, it's something between an infrastructure as a service and a platform as a service, something in between. ORAN defines instead the deployment scenarios on the OCloud, how the different functions should be deployed here. The RAN intelligent controllers are of two kinds. The non-real-time is in control of long-term control loops, longer than 1 second, is where you define the policies for the intent-driven RAN, is where you could have model management for machine learning, and you could ingest enrichment information. In example, you could decide to optimize the behavior of a certain set of cells depending on traffic, a special traffic peak for an event that is happening there. And this is achieved through RApps. RApps are actually the different applications controlling the advanced use cases. In the near real-time REC on the left-hand side, actually you control short time control loops between 10 milliseconds and 1 second. This is done by the X applications, X apps, which are really controlling the influencing the management of radio resources, RRM. And basically, the near real-time REC is in charge of talking to the RAN elements in order to influence their behavior. Again, it's a platform with X apps, a lot of common functions, some related to security, even though not very well specified as of today, shared data layer, communication bus, and something about conflict mitigation that we will see specifically later on. Let's finish this part by talking about some ORAN use cases. I tried to classify them in 3 large classes. Some of them are oriented towards specific verticals or customers, like the vehicular applications, V2X, or the control of drones. Some of them are quality oriented, like optimization of the quality of experience for mobile gamers, in example, or the quality of service, in example, for rescue teams in case of emergencies, a fire, an earthquake, or similar. And then there are a lot of use cases related to the optimization of the telco operations, especially the use of a spectrum, like in 4G, 5G dynamic spectrum sharing, rush sharing, and slicing. Okay, we are at the end of part 1 of the presentation, and I would ask Max to share the poll that we have for our guests. Please, Max. Basically, we have 3 questions for you. We would like to know from your point of view, which is the main value of ORAN, the idea of openness, with all the advantages also in terms of CapEx, if we have more competition, the business value, choice number 2, of the new use cases enabled by the intelligent controllers and the apps, or the clear direction set for the use of cloud technologies, basically. What's your opinion regarding this? So I see that votes are piling up, and I see that the idea of openness is getting most of the votes. Really interesting. So, okay, cloudification is important, but also only 20%. But the idea of openness and diversifying the RAN, also for getting lower capex, is getting most of the votes. Very interesting. I thank you. Max, perhaps we can end the poll. I think we have received all the answers. And thank you very much. Really, really interesting to know that the idea of openness is what attracts most of our audience. Okay. Let me continue now with chapter 2 of the presentation. Let's start talking about cybersecurity, and let's see some models for risk modeling. Basically, we'll talk about 2 approaches, 2 different approaches, that just to make a comparison about 2 different opinions. We will start from the ORAN Security Focus Group. This is inside the ORAN Alliance, the group in charge of security studies. They published 4 documents. The latest issue was in March this year. One is about threat modeling and remediation analysis, the most mature. We have a requirement specification, rather mature. One focused on protocols, SSH, mainly SSH, TLS, dual TLS, and IPsec. And this is really about the versions, the encryption algorithms, very specific. And one is about test specifications, which is still largely in progress. And we will see it at the very end of the presentation. Now, let's see the strong elements in the ORAN threat modeling. And these strong elements are on the right-hand side, the columns in the center and on the right of the picture. Okay, on the left, you have the stakeholders, the possible victims, and the possible attackers, but there is no real deep analysis on the role of these 2 entities. While much more ORAN says about the assets, defining 30 data and interface assets, and 12 components of ORAN. The threats are identified in terms of the targets, ORAN, cloud, open source software, down until machine learning. Security measures as defined inside the documents that I mentioned before, the threat modeling, the requirement spec, and the protocol spec. And the risks are classified as low, medium, and high. Let's see how. Let's see how all these items are combined together to define a threat modeling. The first thing that ORAN does is studying the assets, defining the assets. So starting from the 30 data assets, they are mapped onto the 12 ORAN components hosting those and interfaces where this information is exchanged. And this all is mapped to protection goals at rest or in transit, or in terms of protection of confidentiality, integrity, availability, authenticity, or against no reply for all this information. Then, number 2, threat definition. ORAN tries to define threats against the ORAN components. The most mature piece of a job is related to threats for the ORAN components themselves. This is not a surprise. So ORAN define 9 common threats, 3 threats for the X apps, 4 for the R apps, 2 for the non-real-time controller, and so on and so forth. While all the other items are less, let me say, studied in less depth, because we have only 5 threats identified for OCloud, while OCloud security will need an encyclopedia by itself, as we know. Only 2 threats for radio network. This study is delegated to FreeGPP. And finally, what happens? That all these threats basically are mapped against affected data assets and affected components. Also against the attackers, but not so deep. So the main job is mapping threats against data assets and components. The last part of the risk modeling of the job is related to really risk modeling, because starting again from 1 and 2, asset definition and threat definition, basically we conclude the job with a threat to risk mapping, where the threats mapped against affected data assets and affected components are basically classified according to 3 risk levels: high, medium, and low, and especially from the point of view of confidentiality, integrity, and availability of information. And the risk levels, high, medium, and low, are defined depending on whether the threat affects privacy. In example, in Europe, this is protected by GDPR or similar regulations. Then, of course, the threat is the risk of a threat is considered in terms of what happens to confidentiality, integrity, and availability. Also important in the classification is the number of affected distributed radio units. The higher the number of affected units, the higher the risk. And there is also something related to synchronization, which is really related to physical aspects of the of ORAN. Well, now let's see a different approach. This is the approach of a German Federal Office for Information Security, the Bundesamt für Sicherheit in der Informationstechnik. They published a paper back in November 2021, recently translated to English. In their analysis, they take into account the victim and the attacker perspectives. The victims can be end users, state or society telecom operators, and the attackers could be an end user, outsiders, insiders, or other entities that you see in this slide. But their analysis of the roles of these entities is deeper compared to what they do in ORAN. Of course, they define assets in terms of cloud, interfaces, apps, and machine learning, and targets. Their targets are in terms of confidentiality, integrity, authenticity, availability, and privacy of the information. Security measures, BSI does not define security measures, but tells you you could use FreeGPP security measures, ORAN security measures, both of them or none of them. And again, they define risks in terms of low, medium, and high options. Let's see how they combine all these. Basically, for each one of the assets that ORAN, BSI defines, in example, an interface, they produce a table like this, where on one side you have the different attackers, outsiders, users, or insiders. On the top of the table, you find the possible victims and users, the state of a network operator, the different protection goals that each one of the victims could have at stake, like confidentiality, integrity, availability. Z is authenticity in German, P is privacy. Then for each one of these combinations, you have 4 options, because you could have a higher or lower level of risk depending on whether you have applied the ORAN security measures or the FreeGPP security measures, or both of them, or none of them. And this, of course, gives you none of them means highest risk. And for each one of these cases, then you have green, yellow, or red, depending on low, medium, or high level risk. So a very analytic kind of job in order to define the risks, really, really in depth and complementary compared to what ORAN with a security focus group does. Okay, now we enter into chapter 3. So we'll offer you a more, let me say, a more practical point of view, our security perspective. So we'll dig a bit inside the different bits and pieces of ORAN, trying to understand which are the risks on the different components. But before we move on, I would ask Max to propose the second poll. We have 2 polls in our webinar, and the second one is related to your point of view on cybersecurity troubles. Okay, so the second poll is really connected to the first one. So we would like to know from you, which should be the main ORAN security concern for an MNO. I mean, the larger attack surface due to the introduction of apps influencing the RAN behavior, or the risks coming for deploying RAN on the cloud instead of monolithic and closed RAN. And the first choice is the complexity of the security when you have a fragmented and multi-vendor landscape of RAN technologies. So opening cloud deployment or new applications, which are your concerns, your main concerns? This is the question. Okay, votes are piling up. Interesting to see that while in the first poll, RICs and apps were not really voted, now they're getting a lot of attention. 40% of the voters actually think that introducing new applications inside the RAN, we will introduce new risks and we will expand the attack surface. Very interesting to know. And also the fragmentation. Second in ranking is the complexity due to a fragmented multi-vendor analysis, and risks coming from cloudifications are not really at the top of your concerns. I mean, still 27%, significant, but the lowest percentage. Okay, I thank you. Thank you again, Max. Please, we can close the poll now. These are the results. 33% first, 27% second option, 40% third option. Okay, thank you. Okay, let's start now talking about ORAN, the ORAN components, and the main concerns we should have when talking about the bits and pieces of ORAN. So, let's start from the service management and orchestration, the control room of the cloudification of ORAN. So let's see on the left-hand side, the top risks. What do we have inside the SMO? We have all configurations data, all network topology data, the KPIs of the network, of the RAN itself, and of your cloud. So very sensitive information. So risk of leakage of network information data. Second large class of risks are related to service denial, degradation, or taking control of service. In example, this could happen in a very brutal way by attacking the OCloud or the ORAN functions from the SMO, aiming at denial of service, brute force attack, let me say. But sometimes you could play more sophisticated attacks by manipulating the configuration files of RAN elements or the descriptors themselves of the RAN functions to be deployed over the cloud in order, in example, to disable some functions or some cybersecurity functions like opening backdoors. Well, the security controls here are mainly related to making sure that data is stored safely, encrypting all sensitive data, and restricting per function the access to data packets. Also, it's important that you have strong password policies like multi-factor authentication and least privilege for all personnel users accessing the platform, role-based access control or attribute-based access control. And since you will maintain here all the software pieces and the artifacts, the life cycle must be secured. So first of all, you should make sure you have a trustable supply chain. You have a tight version control and safe CI/CD practices so that you insert security controls every time you deploy software from the SMO down to VO Cloud. You should use anti-tampering techniques for the software packages, having an example, crypto signatures, so that nobody can substitute a piece of software with another one, trying this kind of sophisticated kind of attacks. Well, as far as orchestration is concerned, again, ORAN doesn't want to overlap with the job of other recommendation defining organizations like ETSI with ETSI MNO framework or ONAP. So basically these bodies recommends what to do. But we can tell you simply that you should protect very well the descriptors. Here you're deploying functions as code. So protect very well the descriptors for VO Cloud. Make sure the communications between the orchestrator and the cloud are secured. We will see how this happens. And avoid improper direct access to MNO. So people in charge of operations on MNO should be really separate from other roles, like the roles in charge of managing alarms or configuration. Okay, let's talk about VO Cloud. VO Cloud will deserve for sure, let me say, a webinar by itself because it's a huge topic. So let me simply say that all cloud implementations can follow several models. Also, ORAN recognizes this complexity and recommends some options. You could deploy ORAN on your own private telco cloud. You could partner with hyperscalers offering data centers close to the edge of the networks. You could go for hybrid models, mixing the two of them. But out of this complexity, the general recommendations that we feel we should share with you are related to, first of all, making sure that the computing infrastructure is highly secure with secure host operating systems and container deployments. Make sure VMs are really isolated, in example. Make sure you use strong identity and access management, not only at user, but also at application level. So define a matrix of which virtual machines should talk to which other virtual machines. Don't allow an open matrix of communications. Make sure the resources are clearly identified and authorized when accessing, in example, data buckets. Data must be protected at rest and in transit, at rest with encryption, especially the one having the highest value. Networking, of course, you should separate network segments. This is good practice, always good practice. Separate network slices. In example, if you are doing network slicing at RAN level. Use active protection measurements. In example, access control lists between network segments or even firewalls or web application firewalls. Software lifecycle, again, from operating system up to network functions. Make sure that what you boot is what is intended to boot. Use secure boot. Use DevOps cycles, safe DevOps cycles. And again, the last recommendations is about awareness and countermeasures. It's important that you try to log and analyze most of the events related to cybersecurity happening in your network, and that you use the 3 pillars of inspection, detection, and protection, which are also, let me say, our motto in Security Gen. Inspection means audit, tries to see your network as a hacker would do. Detect, have strong analytics, log everything, and be able to trace malicious events from your logs. Protection means do some active protection, take some active protection measurements like segmentations or implementation of firewalls. And we will elaborate further at the very end. Let's have a look now at the interfaces. The main interface is related to the SMO and VO Cloud. Let's start from the O1 interface. This is the interface between the SMO and the run elements, and it's in charge of provisioning, fault and performance monitoring, other functions like RBIT and file management, in example. And here, basically, you use a secure FTP or some RESTful APIs or some protocols used to configure network elements like netconf. Well, ORAN recommends that you should have at least TLS or SSH on this interface, and that you also deploy a framework called NACM, which is a framework for granting least privilege access control for configuration operations to personnel in charge of configuring the network elements, the RAN network elements. It's important also using some user-to-group mapping, in example, via LDAP or OAuth 2.0, making sure that users are defined as members of groups and that you have attributes of the groups very well defined, so that, in example, a guy in charge of performance monitoring is not able to change configurations, in example. The risks, let's try to address the risks for the different interfaces. Well, in our opinion, the O1 interface is a high-risk interface. Why? Well, because basically, if you enter here with a man-in-the-middle technique or simply taking control of the interface from the SMO element, you could go straight for a denial of service attack, just attacking the provisioning of radio elements. The attack's complexity is medium because in order to perform some sophisticated attacks or any kind of attack, let me say, you really need to know a little bit how RAN works, how RAN is configured, which kind of commands you have for the RAN elements. That's why the attack's complexity is medium. It's not the kind of competence that, the kind of skill that the general hacker would have. But if you enter there and you know what to do, basically you bring down the RAN. So that's why we have red traffic lights up here. Of course, you could also leak some sensitive info related to performance, in example, or you could try to manipulate O1 data in order to compromise the correct use of the correct behavior, let me say, of the use cases controlled by the apps. This happens because the app behavior can be based on information coming from the O1. But again, the highest threat comes from DOS kind of attacks. O2 is very similar to O1, but is used by the SMO to control the cloud. So it's where you have the inventory of cloud resources, monitoring and provisioning, again, all the lifecycle management of the virtual machines or containers, the software management. And it relies on several frameworks because here ORAN doesn't define its own cloud. Security controls, anyway, for this interface are related to the use of TLS. And other controls are inherited from ETSI-NFV, in example. Again, in our opinion, the risk on for this interface is high, either through man-in-the-middle or through an access at the SMO level. If you enter here, you could bring down the cloud, going for a DOS attack. In example, you can start launching virtual machines until the resources of your cloud are exhausted. Attack's complexity is low or medium because this time you need to have some kind of expertise on how the cloud works, which is a kind of expertise which is more widespread compared to the expertise related to the RAN itself. So that's why we think that the complexity of this kind of attack is lower compared to O1. And low means high risk. That's why you see red color on the low word. The attacks basically are not really ORAN specific, but rather IT oriented. So you could find more attackers with the knowledge on how to perform those. Now let's start talking about the applications instead, the risks and apps. Well, it's important to say, first of all, that ORAN tells that in case the applications, XApps or RApps are compromised, are attacked, or go out of service, or if this happens to the intelligent controllers, basically the RAN must keep working. So the general services must keep working. But of course, you could have situations where losing an X app or an R app could bring down a specific high value use case. So it's important that you try to understand what happens if you lose an X application or R application. So the risks here are related mainly to service denial or degradation by attacking groups of user equipments or cells. I mean, the attacker could try to alter the policies, tweak the enrichment info, in example, making the RAM think that there is a traffic congestion when there is nothing going on. You could have machine learning data poisoning. You could inject conflicts, induce an application to exhaust all the radio resources, going into conflict with other applications. In example, these are the kind of risks against the advanced use cases, against the applications. And of course, you have other risks related to the sniffing of network data or UE related data, user equipment related data. Because in, I mean, the applications, especially the ones at near real-time level, needs to manage identifiers of groups of users in order, in example, to provide a better quality of experience for a certain group of users. So if you're able to read these identifiers, either from the platforms or by sniffing on the interfaces, you could identify the presence of some groups of user equipments on some cells. So even being able to locate some groups of users, and this is sensitive information, of course. You could also leak network data or machine learning data, and this has a high, this is a high value intellectual property. So what should you do here to protect this platform? First of all, you should go for very high level platform security. You should protect very well your platform, applying strong authentication in like multi-factor techniques, strong access control based on, again, least privilege or role-based access control philosophies, and make sure resources and applications are well isolated. The communications between apps inside the RICs are not really standardized or well standardized yet. It's an open point. Also, the role of the security framework inside the near real-time RIC is open for further studies if you read the ORAN specs documents. And so anyway, thinking ahead, you should make sure that the applications are isolated and they cannot steal data each other, or they cannot do lateral movements. Software level security is again of paramount importance with secure boot. Take into account the risks coming from open source software. Have strong software inventory processes and patching processes. Protect software repositories so that nobody can insert maliciously modified apps. System level securities. System level security measures are important too. So you should devise strategies for service survival in case ORAN services are not available, or in case you have conflicts. In example, if one application is trying to make use of all the radio resources in a set of cells, what happens to the other applications? This can happen unintentionally by mistake, or because an app has been modified and is trying to attack the RAN. So you must have some countermeasures, like limiting the number of resources that a certain app can take out of your radio cells. And again, apply data level security, encryption at rest, and strongly access control data buckets. So data buckets must be controlled very well. Also considering that you have a shared data layer inside the near real-time RAN intelligent controller. Now let's see the main interfaces related to, especially to the functionalities of RAN intelligent controllers, the RECs. The A1 interface. The A1 interface travels between the non-real-time and the near real-time RICs. Here you have a policy management, you have enrichment information transfer, also machine learning model management. And here mainly you have RESTful APIs. The security controls recommended by ORAN are related to applying TLS on this interface. Well, what's the risk level here? Well, we assign to this interface an orange level, so not red like O1 or O2, but orange. Why? It is true that here you could attack the RAN by having kind of DOS or service degradation, but this is especially affecting the ORAN advanced use cases. Basically, if you have designed well the sharing of the resources, basically, if you attack these interfaces, you are able to manipulate the intent of the RAN, but you should not be able to bring down or to have a complete DOS of a whole RAN. Of course, you could, that's why here the risk is marked as orange and not red compared to O1 or O2. You could have leakage of sensitive info like subscriber location or identifiers of group of subscribers, allowing you to locate those under certain radio cells. But this is red because this kind of info is sensitive. And then the attack complexity is medium or high, let me say. High with the color green, I mean, if the complexity is high, we are secure. Why? Because in order to perform a smart attack here on these functions, you really need to have a very deep knowledge of use cases. It's not anymore having a knowledge about RAN only, but it's about having a knowledge about use cases for specific applications like flying drones or quality of experience for mobile gamers. So doing something smart in here requires a lot of knowledge. So that's why we think that the risk is lower. And the same happens to the E2 interface, where you have the near real-time controls affecting directly the RAN network elements, like the centralized units, control plane, and user plane. The protocol used here is defined directly by ORAN. It's called E2 application protocol. Security controls here are related to deploying IPsec. Usually you travel longer distances here. So that's why you should encapsulate everything with IPsec kind of technologies. The risk is, again, in our opinion, orange color, because you could have DOS or service degradation but specifically for the ORAN use cases rather than for the whole RAN. You could have leakage of sensitive info, especially here, because in example, the UE user equipment identifiers are exchanged more frequently due to the short control loops. But again, the task complexity is high or medium. You really need to know very well about the use cases in order to make something that doesn't look explicitly like a DOS attack over this interface. That's why the risk is marked as orange, in our opinion. Of course, we are open to listen to your opinion. Well, FreeGPP functions, I will not talk much about FreeGPP functions. Again, for everything that is concerning the centralized units, CP or UP, or the DUs or the radio interfaces, or all the interfaces marked in black color, X2, NG, E1, and so on. Basically, we have the recommendations issued by FreeGPP, like 33.501, 33.511, telling you to apply encryption for confidentiality and integrity, for radio resource control signaling and user plane data. You should rotate the encryption keys frequently. You should apply encryptions also on all interfaces where you have operation, administration, and maintenance communications. And this is what happens on the O1 interface. But we will not repeat here or comment everything that FreeGPP recommends. Just let me tell you that a big piece of the job regarding cybersecurity of RAN is done by FreeGPP and is not replicated by the ORAN initiative. Well, a quick comment on the OpenFrontal Interface, which is the interface between the distributed units and the radio units. And radio units are going to be really located with the towers, where we have the antennas. Here we have a lot of physical functions related also to synchronization. Synchronization is very important between the RAN elements. Otherwise, the frames are not working correctly. And but these are kinds of point-to-point LAN interfaces, so really point-to-point, which should not be exposed over a routed infrastructure. So this layer should be rather hidden, let me say. There are some recommendations by ORAN. ORAN tells to use, in example, the framework specified in 802.1x, which is a framework to protecting specifically point-to-point link, having authentication and authorization also on point-to-point links, in order to make sure that nobody can play man in the middle in here. Let me say that the risk on this interface is between red and yellow, let me say red and orange. Why? Because if you enter into this interface, usually you have raw data and you want to do something like a denial of service attack. You want to attack really almost the layer one, or almost cutting the wire, let me say. But the attack's complexity is medium or high because this layer is rather hidden, should be really point-to-point and hidden inside the transmission infrastructure of the operators. So it should not be easy to access in here. That's why the risk is high, because it's about DOS, but the complexity is medium high. So we classify this risk as between red and yellow. Well, let me try to approach the end of the presentation before I leave the floor to some of the questions. And let me now comment a little bit on the security enforcement recommendations that we have from ORAN, first of all. Let's have a look at one of the 4 documents that they publish, the test specification recommendations. In this document, you find a lot about inspection and penetration testing. An example, about, ORAN recommends to put under stress the robustness of SSH, DTLS, or IPsec. Make sure you use the correct versions or cyber suites. That certificates are properly protected and managed. Passwords, you should test the robustness of the password policies, the resistance against brute force attacks against passwords, and similar. Vulnerability scanning, the next chapter, at infrastructure and application level. Penetration testing is welcome, also with fuzzing techniques. DOS, also try DOS to verify if your anti-DOS measures are working at all protocol levels. Again, a lot of emphasis on inspection, but in our opinion, we as Security Gen consider that the inspection is one pillar of cybersecurity, but not the only one, and detection is really important as well. So it's important that you are able to log all key events happening at your assets, and that you deploy some kind of analytics system based on analytics or knowledge base in order to be able to recognize attack signatures. You should have a way to monitor all the key events happening on your network and being able to spot if these events have a fingerprint of an attack. And finally, protection too is really important. You should apply preventive measures, all best practices from the industry, zero trust philosophy, make sure that applications are authenticated when talking to each other. Proactive measures like firewalls and also web application firewalls when needed. Okay, and I am at the last slide. We are almost at the end of the hour that we planned. I would like to share with you some takeaways. Going back to one of the initial pages of our presentation regarding the reasons behind the ORAN effort. We should ask ourselves why we do ORAN. And let's split this kind of question into 3 main coordinates. On the horizontal axis, you have cloudification. You might want to go for ORAN because you want to push ahead with the cloudification of all your network functions. Well, cloudification, anyway, from the cybersecurity point of view, must always receive the top attention, priority 1, because an attack to VO cloud is deadly. And an attack to a cloud can compromise the RAN, but also other components. Of course, if you lose the RAN, you are an MNO, you have a complete out of service, but you could play more sophisticated kinds of attacks, and you could compromise some other applications like the Mac applications if you are able to attack the cloud where the RAN is sitting. So cloudification is really, must be your key concern. Now let's go to the vertical axis, the other business dimension, introducing ORAN because of advanced use cases. Well, here it's important that you prioritize the use cases. You must evaluate when an attack to an application is deadly for a service, and you must take countermeasures to cater for attacks or conflicts. Make sure that a conflict between, by mistake or by a malicious intention between apps is not completely exhausting radio resources, in example. Trying to make sure that an attack to an app doesn't bring down your old RAM functionalities. And finally, if we move to the axis pointing to us, multi-vendor Run. If you are doing ORAN in order to have a multi-vendor environment with lower capex, you must make sure you have a trustable supply chain. You must manage the security of proprietary, probably, and also open source software components. You must be ready to fill the gaps between the borders between components with a system integrator mindset, because the RAN is not closed anymore, security is not, you cannot blame one vendor only if something bad happens. Finally, let me restate again our, let's say, our motto with 3 key pillars that we in Security Gem believe in as far as cybersecurity is concerned. Inspection, detection, and protection. Make sure that you inspect your network, that you see your network with the eyes of an hacker, that you audit. Detect, have strong analytics, strong tools for logging key events and being able to identify if an attack is going on. And protect, apply proactive measures, firewalls, network segmentations, and everything that enables you to block attacks before they breach in your networks. Okay, I thank you for your attention. We are at the end of the hour, and let's have a look at the question log that we have here. Okay, yes, okay, let's start from one of the questions. Are there any threat models for ORAN that can be referred? Okay, I'm starting from the last one because it's easy, and I talked about it. Basically, for the threat models, I always recommend that you have a look at the documents of ORAN Security Focus Group first. So I go back to one of the previous pages of my presentation. So first of all, yes, this Security Focus Group publishes 4 documents, and I recommend that you should have a look at the first one at least, the threat modeling and remediation analysis. If you want to have another perspective, look in Google the job related to ORAN Security, published by the Bundesamt für Sicherheit in der Informationstechnik, the German Federal Office for Cybersecurity. They published this document in 2021. It's a bit more, it's interesting, very interesting, a bit more complicated to read. So perhaps you could start directly from the source, from ORAN themselves. Okay, regarding the second question, the volume and velocity of logs to identify attacks on RAN will be high, very true. How to manage the logs and identify attacks? Well, yes, CM can be a solution, for sure. A CM can be a solution in order to detect the attacks. There are a lot of, let me say, a lot of tools for analyzing fingerprints of attacks. In example, unusual traffic patterns, communications between virtual machines which are unusual or whose traffic is unusually high. These are the kind of tools which you should deploy, or unusual attempts to enter with certain credentials into an account, in example. These are tools that are very well known and whose visibility can be centralized in CM, and that we recommend that you should deploy. Basically, since SMO is a platform for orchestration, and VO Cloud has a very complete literature related to its own cybersecurity. We recommend that you use a lot all these frameworks, basically. So you should really try to use a lot all the recommendations provided by Etsy or by cloud hyperscalers if you have decided to deploy on a hyperscaler cloud at the edge. Okay, let's see the first question. Can you please share your view on API abuse attacks? Yes, in my knowledge, there is no proper API security management in existing ORAN solution. You are right, because if you have a look at ORAN specification, let me say that not everything is mature enough. So let me go to the slide related to the near real-time RIC. Here you see that one of the platform functions is about security. But then if you start reading the specs of ORAN, you won't find much. You will find a lot for further specification. The same regarding the shared data layers and the messaging infrastructure, where you could imagine that APIs will be deployed, an API style of communication. But again, there is not much regarding these layers. So ORAN doesn't specify these aspects a lot as of today. We must expect improvements. So again, we have an API enablement layer here on the right-hand side, but not very well specified. So again, API firewalls or tools for ensuring that API access is authorized is important. So make sure that the XApp #1 in example can access only certain APIs, that you have authentication through, in example, subscription management services, in order to make sure that only certain APIs can access certain apps can access certain APIs and similar. But again, these are measures that we find in the industry, generally speaking, but are not really well defined in ORAN. As of today, we must expect improvements also in ORAN specifications in the future. Okay. I answered all questions that we had in our question log. So we are approaching the end of the hour that we booked for this event. We started a few minutes late, but I think we recovered. Okay. I thank you. I thank all our guests who had the patience to listen to our presentation today. I hope that you gained something useful from the experience that we wanted to share today with you. Of course, feel free to get in touch with us. You can find us on the internet. You can see the kind of services and solutions that we provide in the market. As I told you, we've been involved in ORAN too in the last year or so. And I also invite you to follow us on our channels, because we will offer you new webinars in the coming months on other topics, like the security of telco workloads on public clouds and similar. We have very interesting webinars that we offered in the past and coming up in the future. So again, I thank you all. Thank you all for your attention, and I hope to see you again for our next appointments. Max, if you want to say a few last words, and then we can close the webinar.
Yeah, thanks everyone for joining. If someone needs the recording or the presentation, it will be shared shortly. Really appreciate that your participation, your questions, and your attendance. Thank you so much, and take care.
Thank you, everybody, again. Have a nice day ahead. Goodbye.